Hey guys, so this week I'm going to be teaching you all about something called the unit circle. And fun little fact is I actually love the unit circle so much. It's my number one favorite topic in all of high school math, every year of math. No matter what subject you're learning, the unit circle is my favorite, and I'm so happy that I get to teach it to you guys because when I learned it in high school, I thought it was so cool. It made sense to me, and it's actually what made me want to be a math teacher. So I love the unit circle, and I hope you guys love it too. You will probably wonder when we're first getting started how this relates to all of the SOHCAHTOA stuff that we were doing last week and the special right triangles that I told you would be really important for this week. And you're not really going to figure it out in the first couple of lessons. I'm going to actually leave it kind of a little bit of a secret until next week. I think once you've had practice with the unit circle, then I'll be able to go back and show you how it connects, and it'll be like a 2-minute thing where you're like, oh my gosh, that makes sense now. Instead of trying to teach it to you at the beginning before you even know what the unit circle is. So with all that hype, let's get started. So on Google Classroom, I have posted a link, a document of something that looks like this. This is, eventually you will understand what this picture is, and you'll be able to fill it out really quickly. I highly suggest printing out several copies of the document that I posted and doing, like, I would say at least 2 of them a day filling out. Now, you won't be able to fill it out until the end of tomorrow's lesson, but I would get them printed out ready to go. If you were learning this with me in person, you'd walk in every day and you'd have a little half sheet of paper and you'd fill it out every single day for about 3 weeks. That's how important it is. It's also something that you might wonder, like, oh, I'm just going to ignore learning this because it probably won't ever come back up. If you take pre-calc, it will absolutely come back up a ton. The unit circle is like a really, really big concept that will come back up. And that's why when we decided what would be the most important things to teach you guys in these last 6 weeks, we're focusing so hardcore on the unit circle. So print that out. And starting tomorrow after the lesson, I want you to be filling it out, at least 2 of them a day. You'll get really fast at it and it won't take long. If we were doing it in person, I would give you guys like a 1 minute to fill it out. Alright, so let's start figuring out how we measure angles on the unit circle. The unit circle is called that because it sits right on the XY axis and the origin 0, 0, so think about just regular graphing. That 0, 0 point is right there. It's called the unit circle because we're only going out 1 unit. So this right here, the x-coordinate is 1, 0. It's going up, right? It's a circle, so the radius is the same. So if I'm going out 1, I have to go up 1. So this would be 0, 1, this point here. This point right here would be -1, 0. And then this point down here would be 0, -1. So you can see that this circle is just a radius of 1 centered at the origin 0, 0. Okay, so what if I say, like, with this picture, find me a 70-degree angle? How does that work? Where do we start? Well, let me clean up my screen a little bit. Well, we're always going to start measuring things out here. This is 0 degrees. And we can start counting up going this way. We go counterclockwise. So just to give you a quick one that's kind of already drawn in here, a 90-degree angle, if I go up this way, I'd hit 90 right here, and I know this is a 90-degree angle. And that should make sense because we do know that a flat line is 180 degrees, so if I started here and go counterclockwise, then I would hit 180 degrees right over here because that's a flat line. That should also make sense because we know that there's 360 degrees in a full circle, so halfway around the circle should be half of 360, which is exactly 180. Okay, so then if I go around another 180 degrees, I would get to 360 degrees right here. And you might be thinking, well, wait a second, that's weird, because didn't we just say that this spot is 0 degrees? How is it also 360? And the answer is, it's both. A circle, how we measure degrees, imagine like a spinning wheel, like on the show Spin the Wheel, how you spin and spin, it just keeps going around and around. So we can keep spinning and spinning and spinning and going around and around and around our circle, and I'd be at 0 degrees here, and I go around, I'm at 360, I go around again, and I would be at 720 degrees, and I can go around again, and you just keep adding 360 degrees. So there is no like maximum number. You can just keep going around and around and around your circle, and the degrees can just keep going up and up and up and up and up. So, the whole point of this slide is just to show you that when we measure an angle, we are starting here. This is often called like the initial side of the angle, and you go counterclockwise until you reach the angle you want. So if I wanted something like 100 degrees, well, I know right here is 90 degrees, so it'd be a little bit past, maybe like right here. And then I know that this angle right here is 100 degrees. So this is the initial side, this is the terminal side, terminal where it ends. All right, so let's do a couple examples where we draw that. When it says standard position, by the way, that's just exactly what I just showed you, starting at the beginning, starting at 0 and going counterclockwise. All right, so let's try 240 degrees. So I'm starting at 0 degrees, which is right here. That's my initial side of the angle. This is 0 degrees, and I'm going to go this way until I hit 240 degrees. So where would that be? Well, I know right here is 90. Right here is 180, so it has to be, I must go past both of those. But if I go another 90 degrees, if I go all the way to right here, I'd be at 270. So that's too far. So I know right here is 180, right here is 270, and I'm looking for 240. So it's got to be somewhere in between there. So I just have to know how much further am I going to go. From 180 degrees, how much further do I go? Well, let's see. What's the difference between 240 and 180? That would be 60. So I know from this spot, I just need to go 60 more degrees, and then I'll get there. So we'll just kind of eyeball it. I know that this right here is a 90. If I cut it in half, that'd be 45 degrees. So I know I need to go a little bit more than that, so maybe I'll go about right there. And that's a really good estimation. Let me clean up the screen a bit. So here again is my initial side, here's my terminal side, and I went all the way around counterclockwise until I hit 240 degrees. So that shows me this angle right here, that one is 240 degrees. Okay, let's do another one. How about 500 degrees? Wow, that's a big one. Well, again, if I think about starting here at 0, the initial side of my angle, if I go all the way around the circle, I'm at 360 degrees, which is still less than the number I want to get at. So let's pretend I did that. Let's pretend I already went around the circle one time, so I'm already at 360 degrees. So now we'll just start, that was pretty messy, let me make that neater. So let's start at the beginning again, but instead of thinking about it as 0, we'll think about it as 360 and just see how much further we have to go. Well, I always like to think in 90-degree increments. So if I add 90, so here I am at 360, if I add 90 and I'm up to this bar right here, that would be 450 degrees. And I'm still not there. I still have to go 50 more degrees to get to where I'm at. Okay, so again, let's think about, well, this part is a 90-degree angle. If I cut it in half, that's about a 45. And I needed to go just a little bit further than that. I needed to go 50 degrees. So I'll go pretty close to that. And I think that's a pretty good estimation. And now I know that I have drawn a 500-degree angle, which I know might seem so crazy, but we went around the circle once, and that counts as 360 degrees of that 500. So this is where I would draw a 500-degree angle in the standard position. Now, how I would actually label it is like this. If I want to show that I went around the circle one full time, plus just that little extra, I would just show it like that. Like, show the arrow, like, going around once and then ending here. And that little loop shows me 500 degrees. Now, if I just want to show the part after I did 360, so let's think about 500 minus 360 gives me 140. Just this part to this part, just this section is 140 degrees. So with the extra loop, you get 500. Without the extra loop, you get 140. Oftentimes, you do label both, but as you can see, they end up in the exact same place anyways. So as long as you really just have this part drawn, the actual angle, then you're good to go. All right, let's do the last one. What do we do with negative angles? It's actually really, really easy. That just means you go backwards. So instead of going counterclockwise, you're going to go clockwise. You go this way. So I need to go 50 degrees backwards, which would be, again, just kind of thinking about eyeballing it. 45 is halfway, so go a little bit further than that. So I'll erase that, and I'll just think about going a little bit further. So this degree right here is a negative 50 degree angle because I went backwards. I'm going clockwise 50 degrees. That's the opposite direction, and that is how you get negative angles. Okay, so I need you guys to try a few on your own because knowing the degrees of the unit circle is step one to understanding all the rest of it. And so it's a really good foundation that you really need to have. So I want you to pause the video here, draw 4 circles on your paper, just as best you can. And I would draw each one of them having like an XY axis around here. That way you know to always start here at 0. And I want you to show me on your paper, or show yourself on your paper, where these 4 angles would be, and hit play when you're ready to check. Alright, let's check these over. 65 degree angle would be about right here, a little bit short of 90 by 25 degrees, right? So I'm trying to leave enough room that this leftover space here is about 25 degrees of getting me to the 90. That's how I think about it. Okay, let's do number 2, the 300 degree one. Okay, so I can think about going all the way around the circle is 360, so that's too far. So I need to go 60 degrees less of that. So a kind of a cool shortcut would just think, oh, well, why don't you just start here and do a backwards 60 degree angle? That'd be the exact same thing. And you know what, that's what I'm going to do because that seems a bit easier. So that would be probably about right around there. And how I would actually label it, though, because how I have it labeled right now looks like it asked me to do negative 60 degrees, which isn't exactly what it asked me to do. So how I want to make sure I label it is going this way. This angle here is 300 degrees. Okay, cool. Let's do the next one. Negative 120 degrees. So I'm going to start at 0. This time I'm going to go clockwise. I'm going backwards. I'm going to start by going down. Okay, so if I go this far, I'm at 90, and if I go this far, I'm at 180. And when I say those, I'm at negative 90 and negative 180, because of course I'm going backwards. So that would be too far to go all the way back to negative 180. So once I'm at negative 90, I would need to go 30 more. So just think about drawing an extra little 30 degrees there. So maybe that would be right around there. So let me clean this up a bit. And I would say this angle in here is a negative 120 degrees. I started here, and I went backwards 120 degrees and ended here. Again, just to keep the vocab straight, initial side, terminal side. Okay, last one, negative 450 degrees. Again, if I go negative 360, I'm right back to where I started. So how much further do I need to go? If I'm already at negative 360, and I need to get all the way up to negative 450, how much extra is that? So just subtract them, and you would get 90 degrees. So I know that if let me redraw this, started here, went all the way around, I'm at negative 360, I need to go an extra 90 more, so it would take me back to here. And how I would actually draw my loop is I would show that I went around, and then just an extra 90 degrees. So that whole part gives me negative 450. So this leads very naturally into talking about what coterminal angles are. If we look at example 1b, which let me just remind you, that was asking about the 500 degrees. So let me go back to that screen and we'll write that down. They were coterminal, 500 degrees and 140, because when I went around 500 degrees, remember this was the one where I went all the way around 360, and then I thought to myself, okay, well, if I'm already at 360, how much further do I need to go to get to 500? And when you subtract that, you get 140. So, and that was roughly around here. And so, unless you drew in your extra loop thing and showed that you did that, how would anybody know if you just saw this picture? How would anybody know if you went up 140 degrees and stopped, or if you went all the way around 360 degrees and then went an extra to say that it was 500? How would you know that if the loops were not marked in? And you wouldn't. And so that's why these are called coterminal. If they end in the same spot, like 500 degrees and 140 degrees ended in the same spot, we call them coterminal. Okay, so if you think about like 200 degrees as a different example, what other angles would be coterminal with it? Well, you could just always keep adding 360 degrees, and that would be something that's in the exact same spot. So if I add 360 degrees, I'm at 560. If I add another 360 degrees, I'm at 920. All of these things, 200 degrees, 560, 920, if you were to draw them out, would be in the exact same spot. I could also go backwards. I could have also said, well, I'm going to start at 200 and go around downwards. I'm going to go clockwise 360 degrees. So what if I subtract? What would that be? Well, that would give me negative 160. So I can keep subtracting 360 or add 360, and you're still going to have the exact same looking thing. And that is what's called coterminal. Okay, so with that, what if I give you an example where I say, here's negative 45 degrees. I want you to tell me what's a positive coterminal angle and a negative coterminal angle. That means that it ends in the same spot. So first, let's visualize. Negative 45 degrees, if I have my initial side here, I'm going clockwise, would be right here. This is negative 45 degrees. And what I'm asking you is what other angles have an ending side, a terminal side right there? Well, I could just add 360 or subtract 360. So let's take negative 45 and add 360, and what do you get? You get 315 degrees. What that means is if I were to ask you to draw 315 degrees, so that's positive, so you were to start here and you were to go counterclockwise, you'd go all the way around, and you would end up in the exact same spot. And so it would look the exact same. You would just start here and here. It looks the exact same thing as the blue one I started with. Okay, now the question also wanted me to give a negative coterminal angle, so I just need to subtract 360 to make sure I'm still in a negative number. And when I do that, I'm getting negative 405 degrees. And what that means is if I were to start here and go negative 405 degrees, I'd go all the way around, and then I'd have that extra little 45-degree angle to give me the exact same angle that we started with. Okay, so my final answers were when I added 360, I got 315 degrees, and when I subtracted 360, I got negative 405. All three of these things that I've boxed in, here, here, and here, are the exact same looking angle, and that's why they're called coterminal. All right, so I want you guys to try that now on your own with the angle 395. Give me a positive and give me a negative. Pause the screen here and do that, and then hit play when you're ready to check. All right, so here's the two answers I got. When I wanted to do a positive one, all I did, and I did that over here on this side, is added 360. And I got my answer of 755. If you were to draw that degree, you'd get the exact same looking thing as 395. And then to get the negative one, I subtracted 360 degrees. But when I did that, I still had a positive number. So I just subtracted 360 again, which just represents going around the circle again. It's like spinning the wheel again, but you still end up in the same spot after you spin the wheel. And I finally got a negative number of negative 325. Now, is that the only right answer? No, because with both of these, actually, I could just keep going. I could say, well, I'm going to subtract another 360, and what would I get with that is negative 685, which is also another negative coterminal angle. That would still be correct. Same thing over here. If I wanted to, just for the heck of it, I could add another 360, and whatever I get would still be a valid answer. So there's actually an infinite amount of correct answers because you can just continue to add 360 or subtract 360 as many times as you want, and you'd still end up, if you were to graph it, with the same looking thing. Okay, so I want you to do that a few more times, but before we do that, I'm going to do with you number 5 and number 8. This is the last slide for today, and then you guys are going to do 6 and 7. So let's do a couple together, and then I'll have you do those two on your own. All right, so let's draw an 80-degree angle. Well, I guess I don't have to draw it, but I want to find one that would be positive that looks like the exact same thing. So add 360, and you get 440 degrees. Graphing both those angles will look identical. And now let's take 80 and subtract 360, and what do I get? Negative 280 degrees. So all three of these things visually will look the same when you graph them. Okay, let's do number 8, negative 135. If I add 360, I get 225. Oops, not 255. 225. And if I subtract 360, I get negative 495. And that's good enough for me. If I wanted to, I could do another 360 just for the heck of it and see what I get. And same thing with the negative one. I could have subtracted another 360 to make it more negative. And again, that just means spinning the wheel one more time. So it's not going to change the terminal position or where the spinner ends, you can think. So it's not going to look any different, but it will have a different number because we have gone around the circle one more time. All right, pause the video here now and do 6 and 7. All right, so there's my answer for number 6. That was pretty straightforward. I just added and subtracted 360, and I didn't have to go any further. When I look at number 7, it's actually a pretty big number. Like, I could subtract 360 and get 380, and that's still a positive number. So I could count that one for my positive one. I think sometimes we always get in the habit of adding to get the positive one. So if you did that, you would have gotten 1,100. And that's fine. But if you can subtract 360 and still get a positive number, then there's absolutely nothing wrong with doing that. And as far as graphing, like this one seems easier because you don't have to like go around the circle as many times. Okay, now let's try and get a negative one. So I'm going to start from 380 and subtract 360. And I get 20 when I do that, which is still not negative. So I still need to go one more, subtract another 360, and I get negative 340. I'm going to need to erase some stuff so I can write that in. So negative 340 degrees, that's my answer for the negative coterminal angle. All right, that's it for today's lesson, you guys, is just understanding how to locate angles on the unit circle. So how we go positive, which means counterclockwise, going up from 0 degrees, and how we do negative angles, which means going down from 0 degrees in a clockwise way. If you understood all of that, then you're good to go, and we can get ready for tomorrow's lesson. Have a great day, you guys, and I'll see you then.